So this is the differentiating logs and exponentials and chain rule homework. So we have f of x equals ln x plus e to the power of x, and we need to find the differential of them, and then the second differential. It's super easy, so we can just differentiate them individually. This becomes 1 over x plus e to the power of x, and f dash dash x, this becomes negative 1 over x squared plus e to the power of x. And this is obviously pretty simple, but how did I do the first one here? Technically this is x to the power of minus 1, so differentiating that becomes minus x to the power of minus 2, which is pretty much just this. Cool. So we need to differentiate with respect to x for these values. Again, you can just differentiate them the same way. So this becomes 6x squared plus 4e to the 4x. This therefore becomes chain rule again, so both of them are chain rule. So this is 3 times 2x, which becomes 6x, multiplied by x squared plus 5, because it's the differential of whatever's on the inside multiplied by the differential on the outside, and that's it. So the differentiate with respect to x, so this one here, this is x plus 5 x squared plus 4 to the power of minus 1. So then from here, the ddx of this equals, well, 1 plus, or it's going to be minus 5 times by 2x, so minus 10x, x squared plus 4 to the power of minus 2. And this one here, super simple, it's just this cancels out, so we just get left 2x e to the x squared, and that's it. Cool. So the point P lies on the curve with the equation this with x coordinate 1. So find an equation to the tangent at the curve at point P. So y equals 2 plus ln of 3 minus 2x with x coordinate x equals 1. So find an equation to the tangent at point P to that curve. So we just need to differentiate this. So the differential of this becomes y dash, the 2 goes away, equals the ln of this, so it's going to be minus 2 multiplied by 1 over 3 minus 2x, which equals minus 2 over 3 minus 2x. And then x equals 1 in that scenario, so this equals minus 2 over 3 minus 2, which equals just minus 2. So the gradient of the tangent is going to be minus 2, so y equals mx plus c. So we need to find the equation, so y equals minus 2x plus c. And we need to find the c value. So if x equals 1 in that scenario, what does y equal? So at that point, y equals 2 plus ln of 3 minus 2, which equals 2 plus ln of 1. And ln of 1 is always going to be 0, so this equals 2. So the coordinates where they meet is 1 and 2. So we'll put that into this equation here. So this equals 2 times minus 2 plus c. So c equals 4. So the final equation is y equals minus 2x plus 4. And then here the point P lies on the curve with the equation y equals 3 over 2x plus 1 with x coordinate 1. Find an equation to the normal to the curve at point P. So the point P lies on that curve, so y equals 1 over 2x plus 1, and at the x coordinate we need to find an equation to the normal. So the normal is going to be the 1 over negative reciprocal. The gradient of this, 3. So the gradient of this is the same as 2x plus 1 to the power of minus 1. So the differential is going to be 3 minus 3 times 2 times 2x plus 1 to the power of minus 2. And this equals minus 6 times 2x to the plus 1 to the power of minus 2. And x equals 1 in that scenario. So we just sub that back in. So minus 6 multiplied by 3 to the power of minus 2. So that equals minus 2 over 3. That's 6 over 9. 6 over 9 is 2 over 3. And we need to find the equation. So y equals 3 over 2x plus c. And then we just need to find the y value from here. So y value, we just put x back in. So y equals 3 over 2 plus 1, which equals 1. So the coordinates are 1, 1. We just put that back into here. 1 equals 3 over 2 times 1 plus c. So c equals 1 minus 3 over 2, which equals minus a half. Therefore, the final answer is y equals 3 over 2x minus a half. And that's it. Cool. So the point P lies on the curve that. So I'm just going to, I'm going to cut this. I'm going to paste it down here. So the point P lies on that curve. Y equals 2 over root 2x plus 1 with x coordinate 4. Find an equation of the tangent to the curve at point P. So y equals 2 over root 2x plus 1 x coordinate equals 4. Let's find an equation to the tangent of the curve at point P. So again, it's the same thing. So y equals 2x plus 1 to the power of minus a half. And to differentiate this is just a chain rule. So 2 times the minus half comes down, times the differential of this, which is 2. And then this becomes the same, 2x plus 1 to the power of minus a half, take away 1, which is minus 3 over 2. And this equals 2 times that just becomes minus 2. 2x plus 1 to the power of minus 3 over 2. And x equals 4 in that scenario, so this equals minus 2 times 9 to the power of minus 3 over 2. So the square root of that, I like thinking about it as the square root of that is going to be 3, and then 3 to the power of 3 is 27, so this equals minus 2 over 27. So that's the gradient at x equals 4. So we need to find the tangent. So again, we just need to find the y value. So first of all, y equals mx plus c. So the tangent is going to be y equals minus 2 over 27x plus c. So what's the c value? We're going to have to find the y value for it. So let's put this back into here. So y equals 2 over 9, which is going to be root 9, sorry, which is going to be 3. So let's put this back into here. So 2 over 3 equals minus 27x multiplied by 4. So that plus c. So then this becomes 2 over 3 plus 8 over 27 equals c. So then that is 27, and that is 9, 18. So 26 over 27 equals c. So the final equation is going to be y equals minus 2 over 27x plus 26 over 27. And that's the final answer. So the tangent intersects the x-axis at point A and the y-axis at point B. Find the exact area of the triangle AOB where O is the origin. So I'm going to draw the coordinate axis just to visualize it. So AOB. So the tangent intersects the axis at point A. Oh, okay. So I didn't realize for a second that I meant this line. So yeah, so this line here. So this is 26 over 27. And then this value is going to be whatever. When this is x equals 0. So sorry, y equals 0. So when this equals 0, so 0 equals minus 2x. I'm going to multiply both sides by 27 plus 26. So x equals 2x equals 26. So x equals 13. So this is 13. And this is 26 over 27. So this length is going to be 13. This length is going to be 26 over 27. So then I have base times height over 2, which equals 13 times 26 over 27 over 2, which equals 169 over 27. And it says the exact area, so I'm going to leave it in the fraction form. And as you can see, this is a triangle. I've drawn it on Desmos, so 2 over 2 root 2x plus 1, and then they meet at 4, and it has the x-axis. The equation has a x-intercept and y-intercept that are, I'm assuming they're both correct, because it's 13, and this is probably the square root of whatever I had, 26 over 27. And then the area of that is going to be base times height over 2, and that's it. Cool, lovely, nice.